Hi, this video is the report of a study of wave scattering and its dependence on obstacle sizes using EEP, which is a free simulation software from MIT which uses finite difference time domain technique to discretize space and time and calculate the field values at different space-time coordinate points. So let me just start with my results. So first we took an obstacle size of 1. So the source here is placed at minus 5 comma 0, as you can see, and there's a very small obstacle which is placed at 1 comma 0. So the obstacle has nearly no effect, and so you can see that there is some diffraction that is happening, but the wave mostly goes on, just continues on without really getting diffracted. Now let me increase the obstacle size and see what happens. So in this case we have a larger obstacle, and here we can see diffraction happening clearly because the waves that are going behind the obstacle are interfering, and they are out of phase with the rest of the waves that are going behind. So the waves that are going behind the obstacle they have a different phase than the other waves. Let us further increase the obstacle size and see what happens. So now you can see the third regime that was being talked about in the experiment. So there's sort of a shadowing effect, and there's a very clear region where there's no waves at all. There is still some diffraction, but the shadowing is much more pronounced. So let us increase the obstacle size to a very high value and see what happens. So for this size of the obstacle, the shadowing effect is very pronounced. So there's a very clear blank region behind the obstacle. Let me show you the parameters that were used. So the size of the lattice that was used was 16 x 16 x 16. The block material was metal. The center of the block is 1, 0. The source frequency was set to 1. The source center is minus 5, 0. The PML layer thickness was set to 1, which is the standard 1 wavelength thickness. The spatial resolution was 10, and the time taken for one simulation was set to 200 seconds. Let me just show you the code. So this is the code that was used to run the experiments. So the first line sets the geometry. The size of the block is set to 16 x 16 x 16. The second line sets the block. So the center of the block is 1, 0, and the thickness of the block is set to 0.5. The material of the block is set to metal. The next line basically defines the source. You have the center of the source and the frequency of the source, which is set to 1. The PML layer thickness is set in the next line, and there is time resolution of the spatial resolution is set to 10. Now the 200 now this simulation runs for 200 seconds and writes out the output to a file. So this is the report.